Well, good evening and welcome to Dome at Home, the Manitoba Museum's Planetarium Weekly Live Astronomy Show. I'm your host, Scott Young, planetarium astronomer at the Manitoba Museum, and it's great to see you all today. I see everyone checking in on our chat. You can chat either in YouTube or Facebook, and all of the comments are moved around through the magic of the internet, and so everybody gets to be in the same conversation, which is great because we've got this great community that we've built around this show every Thursday night. Getting pretty nice to see so many familiar names. All right, let's see. Lots of some questions already. Jenny says that was short. I'm not sure what that means. Hopefully we haven't lost a stream. Let's take a look here. We have had, so there's this whole thing where people will claim a copyright violation on your live stream so that they can get all the money that you make from your live stream, because apparently there's like 3 people in the world that make money doing this. And so people make these claims and it basically shuts down your live stream and diverts any revenue to these copyright pirates, basically. And well, the joke's on them. We make nothing from doing this, other than friends, and hopefully a few astronomers as well. But we don't make any good. Oh, good. Okay, so we got the stream is good, it sounds like. So hopefully things are working well. Anyway, it's great to see you all. We will be looking at, well, a couple of weeks ago, we did this show where we showed the video of those fireballs that were seen in the sky over Manitoba. We had 2 of them on back-to-back night. Really beautiful. Ever since then, my email and my phone is lighting up with people that have found rocks. And they're wondering, could they be from that event? Totally valid question. The thing is, most people don't really know what a meteorite, a rock from space, would actually look like. We sort of have these ideas either from, movies or the internet, but most people don't really know. So we are going to show you. We're going to tour the Manitoba Museum's little meteorite display and show a couple of the examples. We'll also do our quiz, is it a meteorite or a meteor wrong? There are a lot of earthly rocks that look kind of like what people think meteorites should look like, and we're going to look at some of those. We will also be taking a look at a new binocular challenge object. Actually, we're a little behind on binocular challenge, so we're going to do 3 tonight, 3 objects. They're all right in the same area, so we kind of have to do them all together anyway. And then we will also have some cool space stuff. Let me see. There is, hi Krishna from Houston, good to see you. And we've got all of our Winnipeg crew, the Swan River crew is here. Hey, Callie. And North Kildonan, sunny North Kildonan, says Stan. That is good to know. If it's sunny now, it might be clear in a little while. That would be great. The wind was nasty, though. I'm not sure that my telescope would stay pointed if I was to set it up in that wind. We've got, the trees are just bending over backwards out there right now. All right. Let's see the questions here. Scott, did I hear interstellar music when I was waiting for the planetarium show last week? Entirely possible. For those of you that have visited us at the planetarium, we are open now Thursday through Sunday. Thank you very much. It's been great to see so many folks coming out. We have a standard background music license, so we can basically play any kind of music that we want before the shows and between the shows and things like that, all totally legally. And so I think the Interstellar CD has made it into rotation there. I still pull out Apollo 13 for some of my shows, and sometimes, it's pretty much the staff person's choice, whoever's running the show, what they pick. Sometimes it'll be Queen, which is equally sort of space opera-esque. All right. So let us move on to one of the things that I can't believe we're already sort of wrapping up. We have been running our Dome at Home astronomy courses. This was something basically based on demand. We always did introductory astronomy courses at the planetarium, but we got a number of requests for sort of more advanced topics as well, more specific topics rather than just here's the one generic class. And so we have run 4 of them so far, and we've got another couple coming up. I guess the next one comes up in a couple of weeks, and it is the one on observing the moon. So we're going to focus on observing the moon through a telescope, talking a little bit about what you can see, observing techniques, eyepieces and magnifications and all that sort of technical stuff, as well as ways to improve your view. And we'll even talk about some photography and things like that. So that'll be fun. And a couple weeks after that, in May, there is one on observing deep sky objects, the galaxies, the star clusters, all those sorts of things. Totally different beasts compared to observing the moon. Even though you're using the same telescope and the same eyepiece, it's a whole different, it's like downhill skiing, cross-country skiing. Both skiing, but very different. So there's still a few spaces in the deep sky one, I know for sure. I'm not sure the moon one might be almost sold out, but you can get tickets through manitobamuseum.ca. Speaking of the moon, Ulrich sent in one of their awesome images here. It's great to see you out and getting some clear skies again. And the moon was a beautiful thin crescent just a few days ago, and I missed it, but I did see it the next day, sort of through some gaps in the clouds. But this is beautiful when you just have this tiny little illuminated fraction, and you can see the dark side of the moon, the whole backside of the moon, in a phenomenon which is called earthshine. Basically, the light that is hitting the earth reflects off the clouds and oceans and all that stuff and back out to the moon and dimly lights up what would otherwise be pitch dark on the dark side of the moon. So technically, there really isn't a dark side of the moon because the earth is always lighting it up. But we only can really see it when the bright side is at its minimum. So this thin crescent, 2 or 3 days after new moon is the perfect time for that. Let's see. So great image, Ulrich. Thanks for letting us share this with the viewers. And let's see. We'll move here. It looks like my PowerPoint is slightly magnified here, so I'm just going to make a quick little tweak. Let me see what I can do. There we go. Okay. So, coming up this week, we're still watching the dance of the planets in the morning sky. The morning is where all the planet action is right now. 4 of the 5 bright planets are visible just before sunrise. And so as sunrise gets earlier and earlier, you have to be getting up earlier and earlier to be just before sunrise. Venus, easy to spot. Brilliant, brightest thing in the sky. You'll see it until almost everything else has disappeared. The sun is about to rise and you can still see Venus. It's so bright. Off to the right, Mars and Saturn really faint. And in fact, you have to catch them at that perfect balance between they've risen high enough to be visible, but they haven't risen so high that the sun has also risen too high and made the sky bright. There's a very narrow window of time, and it's probably going to be different for every person in terms of where you're observing from and how good your eyes are and so on. But in the 15 minutes or so before 6:30 is probably your best bet to start looking. This week, Jupiter joins the scene. It has been basically behind the sun. It's coming out now and is starting to become visible in the morning sky. And as the week goes on, the planets, of course, move in their orbits and their positions change. You have to start getting up earlier. See, here we have 6:15, and you can actually see that Mars and Saturn are much easier to see in this simulation. This is from Stellarium. Stellarium doesn't always get things 100% correct in terms of, when something becomes visible due to the sky brightness. That's a very variable kind of thing, but it's a good guide. On the 13th, Jupiter is rising higher, Venus sort of staying stationary, Mars is moving off to the left, and Saturn is actually sort of moving off to the right in this kind of view, and sort of spreading themselves out. So that's basically the planetary action for this week. It's all in the morning. Starting next week, we'll be able to start to see Mercury in the evening sky, but that'll be coming up a little bit. All right, if we head over to Stellarium here, we will be able to see the constellations as they are. And the constellations, oops, let me just move this over here, are still, you know, Orion is still hanging on there in the evening sky. You can see the belt of 3 stars, Betelgeuse in the upper left, Rigel down here, and then the rest of the hourglass shape for Orion. There is a whole group of bright stars around Orion, sort of forming a big, almost like a circle here in the winter sky. And each one of these sort of belongs to a different constellation. We've talked about a variety of those in different shows. Right now, the moon is right in the middle of that winter hexagon of stars, just up above Orion's head, a nice crescent shape. And so you should be able to see that quite easily if you've got clear skies. Each night, the moon will move on off in this direction. But tonight, that's where it is. So after the show, you know, another hour or so, it'll get darker, and you should be able to spot that crescent moon. I'm going to go outside as soon as the show's done just to see if it's clear enough to see the moon at all. Tiffany is asking about Stellarium. I guess you've got it on your phone. It's asking you to move your phone in a figure 8, but nothing happens. So the way that Stellarium on your iPhone works is basically it uses the built-in gyroscope to tell where you are and where you're pointing and things like that. And the thing is, if it's been sitting in your pocket for a while, it doesn't really work very well. What you need to do is you need to take your phone out and basically turn it around like this a whole bunch of times so that the interior, the guidance system essentially is forced to recalibrate, because this basically messes it all up. It doesn't know where it's going, and it sort of has to refigure things out. So that should improve the pointing accuracy of it. Now, I haven't used Stellarium on my phone yet. I'm going to have to download it and try it. I've only used the free online version and the computer-based version. And of course, neither of those require moving your phone around. So, I'll see if I can find an answer to that and get that for you next time, Tiffany. Callie is asking, if I was to name a star, what would I name it? Oh, that's tough. You know, we have this star naming program through the planetarium. A lot of planetariums do it as sort of a fundraising thing. You can't officially name a star, but you can, you know, donate to a planetarium and they sort of let you adopt a star unofficially. And I've done that a couple of times. I've done it for friends of mine that have passed away. I've done it for people that work at the planetarium, that kind of stuff. So that's usually what I've named it for. I think I would probably name it for my cat or my kids. I probably should have said my kids first, shouldn't I? They don't watch the show, so it's okay. I'll get away with that one. Yeah, I would think that that's probably what I would do. Name it for, you know, some of my loved ones. We had another question here. Oh, Dale is saying you enjoyed Legends of the Northern Sky this Sunday. Awesome. It was it's a great show. If you haven't seen it, we had a pretty busy house even today, Thursday. It's the first Thursday weekday that we've been open in a long time, and the planetarium was really, really busy. So that was great. So thank you for coming out. The planetarium will have some more show announcements coming up soon. I'm pretty excited. We've nailed down our schedule all the way through Labor Day already, but I'm not allowed to talk about it yet. So you'll hear it here first, though. Dome and Home family members get to get the inside scoop on planetarium stuff before the public. So I'll let you know what's coming up as soon as I can. Let's go back to Stellarium here. One of the things that I wanted to sort of point out is that these winter constellations really are starting to fade away. If you want to catch them, you got to get out there pretty early. And probably the thing that I really like about the winter constellations in the springtime, I mean, you can only see them for a couple of hours after sunset, but it's not full on winter, so you can see them without freezing to death. So I kind of like, in March and April, that's when I do all my winter constellation observing really, really fast to try and get in as much as I can before they disappear for the year. There's some great stuff to look at, and that's we're returning to the winter sky for our today's binocular challenge. And I do not yet have a cool theme song for binocular challenge like we do for cool space stuff, so I'll have to work on that. We're going to go to the constellation of Auriga, the charioteer, for our binocular challenge this week. Auriga doesn't look like a charioteer. It looks like a pentagon. And actually, the thing that I always pay attention to, there's the bright star Capella, which is a brilliant white star, one of the brighter ones in the sky. And then right next to it, there's this long triangle of three little stars. And according to mythology, this charioteer, while he's driving his chariot, is holding three baby goats. So these little stars are the baby goats. And I love baby goats, so I kind of remember that. It's not as distinctive as, say, Orion, but the idea of having Capella, a bright star with a kind of recognizable pattern nearby, is kind of distinctive. So you should be able to spot Auriga. It's over in the west, and it's pretty high up in the sky. Inside Auriga, there are some beautiful little star clusters, and they have the wonderful names M36, M37, and M38. The poetry of astronomers when they name things, it's just amazing, right? M stands for Messier, so these are objects from the Messier catalog. We've talked about Messier before. He basically tried to discover comets and found a bunch of them, but he kept coming across these other funny, fuzzy things that weren't comets because they didn't move, and they were just getting in his way. So he kept a list of them so he wouldn't get fooled every single time. And nowadays, we don't remember him for his comets. We remember him for his list of things that he didn't care about. So that's kind of ironic. It's kind of a greatest hits of the night sky, though. I mean, he basically saw all the bright things that were kind of fuzzy and interesting, and he wrote them all down. So nowadays, we use this as a really good reference point for looking at stuff in the sky. So the great thing about these star clusters is they are all within the same field of view of a pair of 7x50 binoculars. If you've got higher power ones, I'm not sure if you can fit quite all three of them, but certainly you can fit two at a time in them. And so basically you just line up your binoculars on the side of the pentagram that is sort of opposite from Capella, so sort of kitty corner from Capella. And in that area, there are three little star clusters. We'll look at each one of them. Now, the binocular challenge is sort of designed for people that want to get a little, a challenge out of pushing their equipment. You're probably not going to see these very well from inside the city compared to what you would see if you get away from the city. And also, you want to pick a day when the moon is not right next to them. So I wouldn't actually recommend this binocular challenge for tonight, simply because the moon is actually just right about there in the sky. So that moon would make it hard to see everything else. But, starting tomorrow, the moon will have moved on. So M36 is a beautiful little cluster. It's got 30 or 40 stars that are all sort of blue-white diamonds all clustered together. In the sky, we don't see all of this background here of all these really faint stars. What we see is sort of the star cluster surrounded by blackness with maybe this star over here and a couple of other ones. So in a photograph, these star clusters actually lose a lot of their luster. But in binoculars or in a small rich field telescope, they are beautiful to look at. They really do look like, well, like the Pleiades star cluster, for example. Just imagine sort of a very faint version of that, because this is much farther away, but the same kind of idea. My favorite of the three is M37. It's the brightest. It's got well over 100 stars packed into the center there, and there's quite a few colorful ones. Most of the stars are sort of blue-white, but there's the occasional orangey yellow one, like right in the middle there. There's sort of an orangey one that really stands out in a telescope for sure, and one on the edge there. Again, you won't see the background as much. You'll just see this sprinkling of stardust all collected in the one spot. Really, really beautiful. M38, I'm not even sure how he saw this and thought this was anything. I mean, it's very big and spread out. it doesn't really have the same impact as the other two. Even M36 is a little bit more compact, a little bit more interesting than this one in binoculars, certainly. But I mean, it's still worth hunting down if for no other reason than you're kind of already looking at it when you're looking at the other two. So for this week, get out there with your binoculars, try and track down one or more of these star clusters. We'd love to see your observations. Just let us know if you found them. Let us know what you did to find them, what your binoculars were and stuff like that. If you had any particular interesting stories of your observing. We just love to hear that people are going out and looking at the sky. And that is always a good thing. I saw a couple things go by in the chat here. Philip asks, what's on your shirt? I see stars. That may actually just be the green screen that is just kind of a mountainy kind of background. But I think the green screen sometimes lets the stars through from the back, from the backdrop. So. But, and Linda is asking, does your closed fist analogy work the same all over Canada if you're not on the flat prairies? Ah, yes. So let me just go back to one of those images. The closed fist idea, if you hold out your fist at arm's length and hold it up against the sky, it covers an area of about 10 degrees. And so what that means is that you can measure things in the sky. Here we put it on the horizon to sort of show that, you know, where these planets are relative to the horizon, how high up they are. They're only 1 fist or less above the horizon. That's not very far. You're right, Linda. If you are in a place where the horizon is not flat like this, but you've got mountains, you actually have to compensate for that. And so if you're looking over mountains, you may not be able to see these planets at all, because even when they clear the mountain ridge or whatever, the sun is already above the horizon on the other side of the mountains, and it has made the sky all bright blue and so on. And so the sky is just too bright for you to be able to see those. But the scale thing still works. Like if you put your fist out and put it on the edge of the horizon, your fist is still 10 degrees up from there. You just, you might not be able to see the things that are very close to the sun if you don't have a nice clear horizon. Even houses or trees, like I can't see them from my backyard because of the trees in my area. So I have to sort of walk to the corner where I'm looking down the street, and there's sort of a gap in the horizon to be able to catch Venus very well. Good questions. Let's see. All right, let us move on. Get a couple of click-throughs here. While I'm just setting up the next piece here, as I said, you can send in your observations. We love to get mail. You can ping us on Facebook, you can ping us on YouTube, or you can email us at space@manitobamuseum.ca. You can send us snail mail through the museum if you'd like. Anything like that is wonderful to see, and it's always nice to hear what people are doing in terms of the observing of the sky. Oh, Nasli's asking, can I star hop you to the constellation of Auriga? Absolutely. So this is the evening sky. This is about 9:30, and so you've got Orion. Oh, where's my cursor? There we go. You've got Orion here with the belt of 3 stars. You've got Betelgeuse, lost it there, and Rigel, and the hourglass figure. If you use the belt of Orion here, and you go sort of to the right, you wind up at Taurus the Bull. This is the V-shaped group called the Hyades, which is the face of Taurus the Bull, and then there's the Pleiades over there. The Taurus, here I'll put on the picture. Taurus somehow is really just half a bull, and it's the face is the Hyades, and then it's got these 2 long horns up like this. Well, the top horn is actually shared with the constellation of Auriga, and here is Auriga carrying the baby goat, and for some reason he's also a charioteer, which is kind of bizarre. But That's usually how I go. I find the Hyades, I go up the horn there, and that's where the pentagram is connected to. So it's a relatively straightforward star hop, and just takes a little bit of practice. But once you've done it once or twice, you'll it's like riding a bike. You can pretty much do it anytime at that point. Okay, we're going to go to our feature here, meteorites. Let me first tell you, if you think you have found a meteorite, you probably haven't. I'm just saying that because it's probably true. That doesn't mean you shouldn't get it checked. I know for a fact that out there in Manitoba, there are probably a half dozen or more meteorites that have fallen sometime in the last 50,000 years or something like that, that are just waiting to be found. Or someone's found them and doesn't know what they are, and they're just using them as a doorstop. That's actually a real story from one of the Manitoba meteorites. But here's the thing. Meteorites are extremely rare. There are 13 meteorites that have ever been recovered in Manitoba. Ever. 13. We get maybe one rock every week that comes down to the planetarium. And the planetarium's been open 52 weeks a year for 50 plus years. And none of them has ever been a real meteorite except once. And it turned out that the guy had bought it online and brought it into us to sort of get an independent verification without paying for it. And so yeah, we got really, really excited. And then he told us that he bought it from a dealer in Arizona, and we were very disappointed. Anyway, that is the facts. They're very, very rare. So when we look at meteorites, we're often looking at what we call meteor wrongs, rocks that kind of feel like they are unusual, but are just unusual rocks here on the Earth. The cool thing about geology is that there are many, many unusual rocks, and each one has a story that dates back billions of years, perhaps, to the very formation of our planet. Each rock is super interesting. But as soon as people find out that they're not meteorites and that they don't have any sort of value to them, they don't even want to carry them back to their car often. So I've got this big collection of meteor wrongs that people have just left in my office, basically. We turned some of those into an exhibit. And so I'm going to give you a little tour of our meteorites exhibit just to show you what meteorites are like and what they're not like. First of all, the real thing. These are two meteorites from a famous event in Alberta where there were lots of pieces that were found. A big meteor, a big fireball came in, exploded, people heard the sonic boom, and pieces were scattered all over the place. And I think it happened in the winter, so these rocks were just lying out on the fresh snow, and so they were easy to find. Really, really cool. Anyway, they're dark colored. They are very heavy for their weight. If you pick one up, it just feels heavy. The inside is kind of gray in this particular case, but also there's what's called the fusion crust, a thin black layer that coats the outside. People often think that like the outside of the meteorite will be all melted and bubbly and stuff like that because it came through the atmosphere, right? Well, here's the thing. When a meteorite is coming in and it's being heated up by crashing into the atmosphere, it's going, tens of thousands of kilometers an hour. That's a lot of wind. Anything that gets molten on the meteorite is immediately blown off and falls off the back, essentially. It's a term called ablation. It's the same thing that happens with heat shields on spacecraft. You do that to help carry the heat away and so on. But that means that the only part of the meteorite, by the time it gets to the ground, that has been melted is the very thin, less than a millimeter fraction of the outside, because all of the rest of it has already been blown off. And you can kind of see in this image here, it's kind of smoothed out aerodynamically. Like there are kind of flow lines here. You could almost see which direction it might have been going as it came through the atmosphere. So that's a sort of a given. If there are bubbles in your rock, it is for sure not a meteorite. Bubbles have to be made from gas, and there's no gas in space. and you don't get any gas when you're coming through the atmosphere at 30,000 kilometers an hour. It doesn't go into the rock because, as I said, is the melted parts come off very, very quickly. Here's a couple of other ones. This one, unfortunately, doesn't show all that much, but it is a piece that is cut and then polished to show the inside, and you can see the internal structure. Very small little pieces, sort of all conglomerated together, make up the inside of a meteorite. There's no big crystals. There's no big chunks of other kinds of rock mixed together or things like that. It kind of looks like all the pieces kind of belong together. They're also often magnetic because they have a lot of, even the stony types have a lot of iron in them. And then there's the iron ones that are literally made out of iron with some nickel in them. They are a solid piece of metal. It feels like picking up a piece of, like a brick of steel or something like that. This is a piece where it's been sliced open and then polished with acid to show the crystalline structure of the metal there. This kind of structure only happens in meteorites, so that's kind of a diagnostic test for iron meteorites versus, say, a piece of iron from here on the Earth. Roger is saying the Homewood meteorite was used as a doorstop in my apartment. Really? Are you serious? Oh my gosh. Yeah, the Homewood meteorite, one of the, actually back then it was only 8 meteorites that were known. Oh my gosh, Roger, we're going to have a little chat, and I'm going to have to get that backstory because, you know, obviously a big heavy rock would be a very useful doorstop. But let's chat offline. I'd love to hear more of the story, and then we can bring it to the visitors here, the audience. That's incredible. Now, I have gone out in the field trying to look for meteorites, and if you've ever walked down a gravel road looking for rocks, there's a lot of them. And so the trick is, how do you know the difference? Well, part of it is knowing what real meteorites look like. If you've seen meteorites before, you can pick up a rock and suddenly say, no, this isn't a meteorite. You can just tell. There's something about the features of a meteorite that just don't really occur on earthly rocks. And there's things like quartz crystals, for example. Quartz, the most common mineral on the Earth, found in lots and lots of rocks, never found in meteorites, period. So if there's quartz crystals there, you know for sure it's not a meteorite. So you can avoid picking up too many rocks. Because let's face it, if you have to bend down and pick up a rock to look at it, and then carry it around as you're walking up and down the field or the road or whatever, your pockets get pretty full. And you're carrying a lot of stuff. So it's nice to be able to rule those things out. Once you've seen real meteorites, though, they're pretty distinctive. This is a chunk of the Campo de Cielo meteor that fell in, I think it was in Chile, a long time ago. There are many, many pieces of this available. It was a massive piece. And so there's lots of examples of it available. We bought this one from a dealer so that we could have one as a touchable in the science gallery. So you can actually pick this up. It doesn't fit out through the bars, so nobody can walk off with it. But you can pick it up and get a sense of how it feels and so on. It was, and you can see it's well loved. The edges are very well worn there because everybody picks it up. I mean, you can touch a rock from space. And this rock that you can pick up here is older than any rock you can possibly touch on the surface of the Earth. This rock probably predates the Earth in terms of its formation. So that's pretty cool. Here's our Meteor Wrong quiz. We have 10 samples, and they all kind of look like what people would think meteorites look like. And only one of them is an actual meteorite. And there's a computer screen there with a keypad, and so you can sort of enter in your guess, and it will tell you what the thing actually is. So you can go in and do all the stuff. I'll just show you a couple of the close-ups just to give you a sense of some of the kinds of things that people will see. This one has this sort of burnt outside crust to it. Definitely looks like it's been through some heating. Not a meteorite. This one here This one kind of, similar kind of thing. You've got these, it's very dark, it's very heavy. You've got these kind of cracks in it. It feels like it's got a burned outside. Also not a meteorite. This one here, it's got that crust on the outside that looks like it's broken off, and then it's got a lighter inside. Very heavy, a little bit magnetic. Not a meteorite. So these last three all came in the door from someone that wanted to know if they were meteorites or not. And then when they found out they weren't, they let us keep them and we put them into the exhibit. So it's kind of cool. This one actually is an ironstone. If you've ever had those, jawbreakers, those big candy things that have all the layers and stuff like that, this is basically a natural one of those that forms naturally. It's called a concretion. And you get these layers of minerals sort of going out from a central thing, and it's laid down and laid down. And so you get these sort of shells, and so you'll often get things that look kind of like a fusion crust or whatever, but aren't. A real fusion crust, the outside of a meteorite, is paper thin. So here, this one here is probably a few millimeters across. And so even though it looks like it might be legit, it's much too big for that. This is the most common kind of thing that we get coming in. Here you can tell, first of all, it's been through heat. There's some bubbles, there's some molten bits, there's some glassy bits, and there's all these sort of chunks of rock that look sort of embedded in this darker material. It's very heavy and it's very magnetic. And that's because it's a piece of slag. This comes from a foundry or a blacksmithing operation, or some place where they're basically getting iron out of the iron ore. And this is the leftover stuff that still has enough iron in it to be magnetic, but not enough to bother refining anymore. And that stuff gets dumped out all over the place. And then people will get, oh, I need fill for my backyard, or, oh, we need to bring in some gravel here or whatever. And that kind of material gets spread all over the province, because people will say, well, there's no foundry where I found this. No, rocks move around. Rocks move all over the place. Sometimes kind of innocuously, but often because someone has picked them up and then moved them. So sometimes in a truck, sometimes it's literally because a kid thought it was a cool rock and then they left it somewhere else. So the fact that a rock looks like it's out of place, or it doesn't look like local rocks around there, doesn't mean it fell from the sky. And that's also a common sort of starting assumption that people have. If I didn't notice it before, it must have just appeared there. No, unfortunately, that's not the case. Whenever there's a meteor sighting, people notice rocks. And those rocks have probably been there every day for the last year, and they haven't been noticed because people just weren't paying attention to them. Melissa's asking, what's the largest meteorite ever documented and the most unusual composition? Oh, that's a good one. I was down in Chicago, and at their planetarium, they have a meteorite that is about as tall as I am. It kind of looks like the Campo di Cielo, the touchable one that we have here, except it's about 6 feet tall. Incredible. It weighs tons, obviously. There are some unusual ones, but those ones usually aren't large. The large ones are usually the big chunks of iron. If you've heard of Sudbury in Ontario, they mine nickel there. Well, the nickel that they're mining comes from an ancient giant meteorite that is under the ground. That's where the nickel is coming from. So you get some pretty big ones. The unusual ones tend to be quite small. We've got about a dozen or so that are known to have come originally from the moon. A rock hits the moon and explodes and makes a crater, and some of the shrapnel actually flies out far enough away to escape the moon's gravity and eventually makes its way to the Earth and falls as a meteorite. We've even got some pieces from Mars that have done that. So those are kind of interesting. And there are other ones. Many of the other meteorites that we have come from objects in the asteroid belt, from Vesta or from Ceres or things like that. So we've even got some pieces from the asteroid belt. And I tell you, waiting for a rock to fall out of the sky and then picking it up is way cheaper than building a robot that you send out to the asteroid belt to pick up pieces and then come back. Much faster to just wait for it to fall into your lap. Let's see. We have another question here. Have there been any meteorites recovered from the recent 2 fireballs? No, nothing has. That's not too surprising. Often I think that the really, really bright ones tend to explode, and any pieces that come down are pretty small. Usually if there are pieces that come down from a thing, everybody nearby hears a lot of the sonic booms. There's a lot of noise associated with it. That means it penetrated down deep into the atmosphere before it broke up, and we didn't have that with either of these cases. Although, still, you never know. It's kind of a tough area to search up in the Interlake, especially with the water levels as they are right now. Specific places to look for meteorites here in Manitoba and also in Alberta. So, as you probably know, at one point Manitoba was underwater. There was, back in the dinosaur days, we were completely underwater, but also there was glacial Lake Agassiz much more recently, like 15,000 years ago, something like that. The ice age had happened. The ice age started to recede. There was a lot of water from that. Those glaciers that came down in the ice age basically pushed a whole bunch of rocks from way up north and pushed it down into the southern Manitoba. And so you'll see these sort of random big boulders out in the middle of nowhere that were basically pushed there by the glaciers. And then when the glaciers melted, they left them. Well, there's a theory that because of the way the glaciers grew and then receded, that there should be a conglomeration of meteorites in eastern Manitoba, sort of White Shell area and the Winnipeg River system, that kind of area. And in fact, of the 13, I think 6 or 7 of them have been found in that area in eastern Manitoba. So that's where I would go. In Alberta, there's actually been a couple of places where meteorites have been observed to fall and then pieces were found. So there's a couple of spots. And actually, we have a specimen in our collection from Alberta that one of the members of the Royal Astronomical Society went out and collected. This one here is from Buzzard Coulee, right on the Saskatchewan-Alberta border kind of area. And he went out and he found this and gave it to us. He found like 5 or 6 that day. So it was a pretty good day for him. We also have the Elm Creek meteorite. This is the largest meteorite ever found in Manitoba. It's a little bigger than a football, weighs about 11 kilos, and it's actually a broken off piece from a larger meteorite. This is a great story. Tom Wood, the guy that found it, was grading a road, and he hit something that was in the road, and he was concerned he had broken the blade. So we went out and got it, and he saw that there was this big rock that was there. So he threw it in the cab and drove away. And it sat with him for years and years before he got it identified as a meteorite. But he basically feels that like he broke it off from the roadbed, and that road has now been paved over and so on. So somewhere under a highway out by Elm Creek, Manitoba, there's a bigger piece of meteorite just waiting for, well, I doubt it will ever be found since it's under a paved highway. Let's see, what happened to the meteorite that fell in Arizona near Flagstaff and created the huge crater there? Is the crater full of small meteorites? Yeah, Meteor Crater, Arizona is a big hole in the desert, about 2 kilometers across, I guess, that was made by a meteorite, a relatively recent one, something like 50,000 years ago, I think. So that's, geologically speaking, that's pretty recent. It's a beautiful crater. There aren't a whole lot of meteorites that are found anymore because it's such an obvious place that it has been picked dry for a long time. But there are meteorites that have been scattered around there. And there's another one in Odessa, Texas, that's a place, a meteorite crater. There's actually even a few impact craters here in Manitoba. Falcon Lake is one of them. There's a place up in the Interlake. There's actually 3, I think, impact craters in the province, which is kind of cool. And Genevieve is asking, has there been a specific location with the most meteorites found? It's hard to say. I mean, worldwide, there have been a lot of them found. Like Campo de Cielo in Chile, I think they found like 10,000 pieces. Northwestern Africa, they find a lot of pieces because you've got the desert. And so they're relatively easy to spot. Antarctica actually has a lot of meteorites discovered because they're easy to find on the ice. So it's not necessarily that they've more commonly fallen there. It's just that they're easier to find there. There's probably piles of them at the bottom of the ocean that just haven't been able to be recovered, right? Because they when they came in and fell, they didn't land anywhere that anybody could see, and then they just disappeared into the ocean. So there's a whole bunch of stuff out there. We do know, though, that it has a lot to do with farming. When you've got lots of farmers, they clear the land of rocks, and you get these big rock piles that they pile up all the rocks in. And so that's a great place to look, I mean, with the farmer's permission, of course, it's private property, to look for meteorites. And this is sort of borne out by the fact that Saskatchewan has 25 recognized meteorites versus our 13. Now, they're not bigger than us, but they have farming that is farther north, and they don't have the big lakes in the way. And so that kind of explains a little bit. But they statistically have more meteorites than we do, even if you account for that. So to me, that says that there's a good half dozen, maybe even as many as a dozen meteorites in Manitoba waiting to be discovered. So Tiffany asks, other than dissection, are meteorites treated in any way, or would any possible contaminants be burnt off on entry? That's a really interesting question. We're pretty sure, like you're talking 3,000 or 4,000 degrees of heat as it comes through the atmosphere. So I'm not worried about any kind of, chemical or biological kind of thing, even if it had, bacteria on it or stuff like that. Now, there is a theory that bacteria could survive inside a meteorite that went from planet to planet. There's even an idea that, maybe there was life on Mars originally, and some of that life in bacterial form was carried to the Earth, or vice versa. It's possible, but certainly not a sure thing. I think that I would be more excited about a meteor than scared of it in terms of any kind of, like you say, contamination or things like that. Most of the stuff, it's been sitting there for probably years by the time you find it, unless you happen to be in one of those few places where people see it and then the pieces come down immediately. None of the meteorites in Manitoba were from observed falls. They were all meteorites that could have fallen like 1 million years ago and just happened to be discovered then. So it's not like they were fresh. They were sitting out there in the elements for years, decades. Let's see. Jenny asks, aren't there millions of tiny sand grain sized meteorites basically raining down all the time? Yes, indeed. The Earth gets hit by about 10,000 tons of meteorite stuff every day. That's a serious amount. Most of it burns up in the atmosphere, or it's so small that it doesn't, it's just vaporized. But vaporized doesn't mean destroyed. You actually wind up with a layer of meteorite dust in the atmosphere up around, 20, 30, 40, 50 kilometers above the surface. Well, that stuff eventually sort of comes down to the level where clouds form. And if you remember your water cycle from grade 4, raindrops start forming around a nucleus. The water starts to condense on something, a piece of dust or whatever. And then once the water continues to condense, eventually it gets so heavy that it falls to the ground as a raindrop. Raindrops often have meteorite dust at the center of it. Well, and Ben just hit it right there. Check your eaves troughs. You can literally go through your eaves troughs with a magnet and then put that magnet under a microscope, and you will see metallic particles that you have collected from the rainwater. Now, they're not all meteorites, because the other sources of metallic particles in the atmosphere, unfortunately, are all the internal combustion engines that are driving around. But the ones that look round, almost perfect spheres, are what we call micrometeorites. You can collect these in your eaves troughs. It's super cool, and you don't even need a microscope anymore because there's those apps that you can get on your phone to to magnify the view. And actually, there's a really cool do-it-yourself thing. I think we put it up on Dome at Home's webpage last year, where you get a laser pointer, one of those dollar store laser pointers, and you throw away the laser, but you take out the little lens and you use that with your cell phone, and it basically turns your cell phone into a microscope, and you can use that to discover meteorites. I've put off cleaning my eaves troughs this year, or last year at all, and when I clean it this year, I'm going to go through everything with a magnet and see what I come up with. There's a guy on Facebook that actually has written a book on this and is collecting just piles of these tiny little micrometeorites. Really, really cool. Let's see. Petra, hey, nice to see ya. If you see a large fireball, is there anywhere to find out about it? Is there a space junk arrival website or meteorite big enough to notice announce page? That's a great question. I'm going to drop a link into the chat. So fireball.imo.net, International Meteor Organization. They take reports, and then they also do the follow-up. I'm just going to switch over so that you can see my browser. Let's see here, browser, click over, and this one here. So here's that site. So you can, you can fill out the quiz. It's just sort of, I'm not going to fill it out because then it's falsifying data, but basically it asks you some questions. It asks you which way you're looking and blah, blah, blah. And then after you've reported it, you go over to the events page. Here are, so far this year, there have been 274 fireball reports in 2022. Let's go to the one that we saw just a little while ago. It was event number 1984. Good year. And when you click on it, here are all the people that reported it. And let's see, I'll put on their, basically, this is the directions that they were facing when they saw it. And you can see that these lines go all over the place, obviously. It's kind of a mess. But what they do is with enough, like there's 110 people that reported it here, they're able to sort of average out all the individual errors and things like that and come up with, this is the actual path of the meteor. And it was basically right over the central interlake, just east of Lake St. Martin, which is ironic because Lake St. Martin is the rim of an impact crater from hundreds of thousands of years ago. So if you want to go looking for the fragments from that meteor, you probably want to head into in around all the Saint Lakes. There's Lake St. Peter, Lake St. John, and so on. So that's probably where you want to go. And look at all the images. Everybody in their doorbell cameras or their dashboard cameras have all these great images. So IMO basically has all this information for that. So if you ever see something, I always recommend go there and report it, and that will also show you who else has seen it. All right, okay. Oh yeah, eaves troughs, gutters. Yes, that's there's the whole Canadian, U.S., British differences in what we call things. But yeah, it is the gutters. You can also just leave out, like if you've got a rain barrel or something like that. Actually, a rain barrel is perfect because the water, anything in there settles down to the bottom. And if you've had a rain barrel in your yard for like 20 years or whatever, you got 20 years worth of sediment to go through. You do need a really strong magnet though, because these are little tiny things and they're probably covered up with mud and they're in all sorts of goo. Don't do it in your best clothes because it's definitely messy, but certainly worth checking out to see if you have some micrometeorites in your rain gutters. All right, we just have one or two more things here. Let me just get rid of that, and it is time.
Rules space stuff.
Okay, so just recently, Canada lost one of our original 6 astronauts. Bjarne Tryggvason passed away just this week. He was one of the first 6 astronauts that Canada selected. He got my job. I applied. I was 12. He had a PhD in engineering, and I was 12. So I imagine there were some class or qualification differences. He probably had an edge, but still, I've never really forgiven him. I told him that when I met him in 1997, and he laughed. So that's good. This was the Canada's Astronaut Corps in 1983. Look at these outfits. No space people wear beige? I'm sorry. It's just, and red turtlenecks. Wow. Anyway, despite the fashion faux pas, all of these folks, except for one of them, went on to go into space. Of course, Marc Garneau flew in space 3 times, is now a member of government. He was the first Minister of Transportation to have been an astronaut. That's a pretty good qualification for Minister of Transportation. Steve McLean, Roberta Bondar, of course, first Canadian woman in space. Bob Thirsk spent time on the space station. Ken Money was recruited to the astronaut program, but got a little discouraged with the fact that it was not happening as fast as he would like, and so he decided to go back to his. I think he was teaching at a university and working in private industry. So he never actually flew. But then, of course, the second class came in, and that's where we had Julie Payette and Chris Hadfield, and now we've got our third and fourth classes of astronauts. All of these folks have now retired, but Bjarne is the first one to have passed away. So we have him in our thoughts today. And you're right, Philip. It does take confidence to sell beige jumpsuits and red turtlenecks. Definitely, confidence is not a quality that any of the astronauts that I've met are lacking. I mean, you have to be pretty sure of yourself to have made it through that selection process. And then once you've flown in space and had to do all of the multi-year training and things like that, you're pretty confident about most things, I would say. So yeah, the fashion wouldn't be an issue. We also have this great picture. As we talked about before, the Artemis rocket, the one on the right there, rolled out of the pad a little while ago, and they were doing the fueling up sort of test. That actually had a couple of glitches, not with the rocket, but actually with the platform that it sits on. And so they canceled one test, and then they started again the next day, and they ran into another problem. And then they sort of put things on pause because the rocket on the left, the Falcon 9, was supposed to come out and launch. So it's launching tomorrow morning about 10:17, I think the central time is. And that's taking the first private space mission to the International Space Station. No government astronauts on board. There is one retired NASA guy who's commanding things, but they're all paying customers. And so that's another big step for commercial spaceflight. And then after that launch, they'll go back to the tests for Artemis, and everything they learned from that will go into this summer's launch up to the moon. So that's a pretty exciting time, and we're really, I can't wait to see, that big rocket go off to the moon. Because again, the second one, assuming the first one works properly, the second one will carry a Canadian and 3 Americans around the moon the following year. Let's see. So we have come to the end of our program for today. It's been great to see so many of you. I do see you there, Terminator X. Nice to see you. Glad you could make it. You'll have to watch the YouTube archive to see what you missed. Yeah, we had a couple of really bright meteors, like once in a lifetime events, but they happened one day after each other, which is really, really unusual. So that was a big thing. Yeah, it's been a great time with you tonight. Get out there and observe the clear sky. It's warming up, try and stay dry. Once your feet get wet, it gets cold really, really fast. So, when you're observing, stay dry, have a great time. And we will see you all next week when, next week we will be celebrating Yuri's Night, the anniversary of the first human in space. That's normally celebrated with a party, and we're still not at the party stage yet at the planetarium, but we'll be talking about it on Dome at Home and be pretty excited to think back to that very first human leaving the Earth, and then where we've come since then. So that's part of our program. We'll see you all next week. Visit us at the planetarium, drop us an email, and make sure you fill out the survey. My bosses love to hear what you'd like to see in the future. We're still working on the May and June schedule, and so there's still a couple of slots. If you have ideas for programs, drop me a line. I'd love to make sure we provide the content that you'd like to see here. Thanks again, and we will see you all next week. Good night.